Today, we're going to present to you a design guide that was developed through an extensive collaboration between academia, industry, and government, all to make it easier to install healthy lighting in our office buildings. So I'm pleased to introduce our partners on this endeavor that have been shepherding this design guideline from its inception to its publication. So Dr. Mark Ray from the Lighting Health and Research Center, which is based out of Mount Sinai in New York City. He has brought along his colleagues, Ms. Jen Bronze, as well as Mr. Dan Fraring. And then we also have Mr. Adam Lillian, who is from UL, that will be speaking today. I will go ahead and hand it over to Dr. Ray so that we can dive into our discussion today.
Let me begin with a couple comments. First of all, I think the most important thing to remember is light isn't just for vision anymore. There's been a lot of science in the last 20 years in particular that indicates that light is, if you will, comparable to diet and exercise. So I see that for a healthy person, Mediterranean diet, 10,000 steps a day, and bright days and dark nights are the platform for good health. And so we're going to talk about the light-dark story today, which we very much appreciate GSA's interest in trying to get this in to have healthy occupants in your buildings. I think this is terrific, and I can't tell you how much I appreciate it. Now, the point of this UL Design Guide 24480 is not everything. We're not dealing with shift work. We're not dealing with jet lag. So this is for people that are active during the day and normally asleep at night. So it isn't everything, but it's for 90% of the people that occupy GSA buildings. So our objectives today are to get you to understand better about the design guideline, which is part of the P100 reference that you should follow. We're going to talk about circadian rhythms and their importance for sleep and depression. We want to have you at the end recognize the role of lighting, not just for vision, as I said, but also for what we call circadian entrainment. And that means synchronizing your wake sleep cycle with sunrise and sunset. That's what entrainment means. We're going to talk about how to implement the design guideline, and we're going to talk specifically at the end about how does one verify that you achieve what you thought you were going to achieve. So there's literally 75 years of work in lighting, generally through the Illuminating Engineering Society, to support vision in buildings. And if you read it carefully, it's what's called visual performance. So the idea is that the lighting recommendations should support speed and accuracy of processing visual information, with the assumption that that's directly related to productivity. That's the role that presumably lighting can play in this. Now, you'll notice that today, nominally, we have 300 lux on a horizontal surface, but 50 years ago, it was 1,000 lux. So we had much brighter interiors 50 years ago, before the energy crisis in 1972. But in that 75 years, there's been no mention about light for sleep and well-being, and yet it is such a profound importance for people that can better sleep and not experience some of the maladies that may be emerging from what we call circadian disruption. So illumination should support both visual performance and sleep and well-being. And I think that's the main message that I want to get across today, that, as I said, light isn't just for visual performance anymore. We need to begin to think about, as engineers and designers, how can we promote sleep and well-being in building occupants. So I want to do a shout out to UL. UL has a long history of being concerned with safety, and I think we all recognize the UL logo. We approached UL back in 2018 and asked them to help us develop a design guideline. I hadn't really known what I was asking for when I did this, but I want to point out that the UL design guideline, as all UL documents, must follow this collaborative standards development system, which is very formal, and boils down to basically ANSI's essential requirements of things like openness, lack of dominance, balance in committees, public review. And you can see here the process we went through. We have to go out for public review in May in 2019, we had 74 pages of comments back. We then respond to those comments, we send it out again, and then we have to reply to those comments. And it was finally published in December 2019. And I'm sure you all remember what happened in February of 2020. So there's been a bit of a hiatus in this discussion, but hopefully we're all back on track again. This is the group that participated in the development of the design guideline. You'll see Brian Steverson representing government, Adam Lillian representing Underwriters Laboratory, but as Brian said in his introduction, we had academia, government, and manufacturing all supporting this particular design guideline development. Now, I want to repeat what I said before, is that the document is intended for those people who design lighting in buildings and want to provide circadian entrainment, that is the synchrony of your sunrise and sunset with activity, wakefulness during the day, and a sleep at night. So again, it's not for shift work. Now, what we're going to do today is we're going to talk about the lighting measurements and the lighting specification methodology and the verification. So this is a complete package. It isn't just good intentions and hoping for the best. It's in fact a way of specifying, measuring, and then looking at whether in fact you got what you thought you were going to do in the design. So let's start with what are circadian rhythms. Now, circadian comes from two Latin words, circa meaning approximately dies. And you have a clock literally in your brain that cycles roughly approximately every 24 hours or every day. Now, if you're in a dark cave, you will continue to have circadian rhythms, and you will, though, however, not become synchronized with your other people that might be down in that cave. Everybody has a slightly different timing in their biological clock, but it's the sunrise and sunset that synchronizes all of us socially to be, as I said, awake during the day and asleep at night. And this is true for every species on the surface of the earth: nocturnal animals, plants, animals, and of course humans. So what are we really talking about in terms of things we can see or measure with regard to circadian rhythms? What you see on the right is things like, say you get up in the morning, your blood pressure rises. You may or may not know that many heart attacks occur early in the morning. It's not randomly distributed throughout the day. But then you have alertness coming in, you get hungry, your blood pressure rises again just before you go to sleep, and then you go through that behavioral cycle. So these are fairly well-defined peaks and troughs of behavior and physiology. Now, if you mess that up, if you're on shift work in particular, but this is true for everybody, it reveals, if you will, the genetic frailties we all have. So you aren't necessarily going to get diabetes because of circadian disruption. That means you don't have bright days and dark nights. But if your family history is such that you're susceptible to cardiovascular disease, mental problems, gastrointestinal problems, circadian disruption makes those more evident than they would be by chance. So a wide range of symptoms, but not everybody's going to experience them. Again, it's this disruption that reveals the frailties we all have in our genetic background.
Hi, this is Kajimel. I have just a quick question, which is, you mentioned circadian rhythm. I think my pronunciation may be a little off.
Yes, that's correct.
Is related directly to sunset, sunrise, etc. So what happens, people living in Alaska or in Northern Pole or Southern Pole, they do not have 24-hour or the day, what we think about the day here, a little bit 24-hour, more or less, day is bigger, night is smaller, things like that. But in those places, it's 6 months. So how their circadian rhythm works?
Yeah, no, that's a great question. What happens is that we've just finished a mathematical model, and I think the bottom line is every photon counts. And so if you are in Fairbanks, Alaska in midsummer, and you get up, all of that light is going to begin to tell your body it's daytime. And of course, by 10 o'clock at night, it's still light and you're still getting this daylight signal and you will be disrupted. So people in Fairbanks need to pull the blinds down and have light shades so that they get a dark environment at night. So they have to intercede when you're in those extreme latitudes to be able to promote daylight and daytime and nighttime. Now, I want to make the point, and this is extremely important, whether you're in Fairbanks, Alaska, or you're in Washington, D.C., if you do not get the proper contrast between bright days and dim nights, you're going to become disrupted in your circadian rhythms. And that's what we're trying to correct. So the principles are the same, whether you're in Fairbanks or you're in Washington, D.C. You want to have bright days, let's say 12 hours a day, more or less, and 12 hours of dim or dark nights. And that's true no matter where you are. And if you don't do that, you are susceptible to those kinds of maladies that we talked about in the previous slide.
Putting blinds on the eyes?
Window blinds, I mean, but a mask would work just as well. If you go to sleep in Fairbanks, putting an opaque mask over your eyes, that's the same thing as pulling the blinds down and having complete darkness in your bedroom. That's a good thing to do, however you want to do it.
I got it. Thank you very much.
All right. No, thank you. Now, as I said, on the right-hand side of this slide, you see this biological clock, and you'll notice that it has 24.2 hours. That's on average, but what it means is that your clock left in a dark cave will cycle every 24.2 hours. Now, the natural sunrise sunset is 24 hours, and so it's the sun, it's the bright days and the dim nights that's going to synchronize your biological clock to the local time, whether you're in Melbourne, Australia, or you're in Washington, D.C. The metaphor we use is this image in the middle where you see this girl in the swing. She swings at 24.2 hours left to her own devices, but it's the girl that's pushing, which is the sunrise sunset, that regulates, for most people, that 24-hour cycle, even though your biological clock is operating at what left to its own devices, operating generally longer than 24 hours. Now, I'm not going to go into a lot of the science of this, but we developed a metric called circadian stimulus, or CS, that combines the unique spectral sensitivity, that is, throughout the electromagnetic spectrum, there's a peak sensitivity to certain wavelengths by the circadian system, which is not the same as the visual system. And then we also have to think about the absolute sensitivity, like what is threshold and what is saturation. So on the left-hand curve, what you see, that black solid curve, is what all the lighting recommendations are based on. That's how the electromagnetic spectrum is weighted. What you see in the blue and the red curve is how the circadian system interprets that same electromagnetic radiation. And so in a very simple way, we're very sensitive to blue light, and so we jokingly say it's a blue sky detector. That's generally what your circadian system is sensitive to in terms of spectrum. Now, what you see on the right-hand side is the response, what we call the response characteristic from threshold, outdoors at night, all the way to outdoors during the daytime. And what you see is that curve, that black curve on the right-hand panel, is the mathematical model, and we've plotted all the data from, I don't know how many experiments that is, looks like 13 experiments. So we have a very good grasp of what the spectral and absolute sensitivities are. What that means is you can begin to engineer a lighting solution by considering both the spectrum and the amount such that you can support circadian entrainment. And I want to add, this is important, without wasting energy. That's the main thing why you need a metric like this. Otherwise, just let them sit outdoors all day, but you don't have to do that to do entrainment. Now, this is a project that was sponsored by GSA, and you'll see Brian is on, one of the authors with us. The orange curve, the orange bars represent those people that sat in their office in dim light all day, and the blue are for people that were sitting accidentally close to a window or had some way to get bright light. Now, we measured that light at their eye with the correct spectral and absolute response from the device we used to measure the light. And what you see is, from left to right, that the so-called sleep onset latency, that means you go to bed, and when is it you actually fall asleep? Well, you see the people that had high light levels during the day are falling asleep very quickly after they go to bed, whereas the people that have dim light toss and turn for several minutes, 20 minutes before they actually fall asleep. We looked at their depression. What you see again is people that have bright light in their offices during the day are less depressed statistically than those people that are sitting in dim light all day. And in terms of sleep disturbances, you also see that they are much less for people that have bright days as opposed to people that have dim days. And so this has been shown on nuclear submarines and with Alzheimer's disease. So this, as I said before, touches every species on the surface of the planet. Now what we need to do is begin to engineer that so that we can provide people with bright days and dim nights in buildings that are otherwise shielded from the natural daylight that you would get. So in simple terms, P100 now recognizes circadian entrainment as part of what you need to do in terms of engineering a lighting system. And to show you, go back to that curve in the center, what you see is the goals we're trying to meet are a CS, circadian stimulus, of a minimum of 0.3 during the daytime and a CS less than 0.1. Now you can see from this graph, we're not all the way up to what would be daytime outdoor levels. What we have found is that you don't have to have super bright spaces to entrain. You just need to make sure that you're up around a CS of 0.3 and have a dim night, and you will be able to entrain and therefore sleep better, less depression, and presumably fewer problems with diabetes and cardiovascular disease, although we did not measure that. So the design guideline, this is the outline for it. It has a preface, a quick guide, an overview. What's important, though, I want to point out the appendices, which give you the scientific foundation for that. And what you have is the links here that you can get to that design guideline, which again supports the P100 Tier 2 recommendations. So here's the quick guide, and just briefly, you set your criterion, you select luminaires, light sources, you perform simulations with photometrically realistic software, you calculate the circadian stimulus that's produced, and then you evaluate whether you did or you didn't meet the design criterion that you set at the beginning. So the first thing we do is in this guideline, 24480, is that we set a stimulus that should be greater than 0.3, and I want to point out for 2 hours a day. It doesn't have to be all day, but 2 hours, ideally in the morning. So think of this as a dose, and a dose is the product of the amount and the duration. So you could, in principle, it's not part of this guideline, you could have lower light levels for longer periods of time and still get circadian effective lighting. So, but I want to make it clear that it doesn't have to be all day. It needs to only be 2 hours at this particular light level of CS of 0.3. Then you select your luminaires. Now, I want to be clear that you're going to select luminaires on a number of criteria, not just circadian effectiveness. So you may have a very intricate, very thoughtful design, but this gives you a chance to see if that design actually meets the requirements of the Tier 2 P100 of a CS of 0.3. So you want to, in principle, think about, instead of horizontal illuminance, you want to think about what fixture is going to provide the vertical illuminance, that is at a person's eye, because it has to get into your eye to be effective for circadian entrainment. So you want to begin to think about not just horizontal luminance. I mentioned at the beginning 300 lux was for a horizontal surface. We're now talking about light that actually reaches the eye. You then pick a light source by the spectral power distribution. Now the mistake that so many people make is they think they can take correlated color temperature or CCT and substitute that for SPD, that you cannot do that, because CCT is a whole different metric that tells you what it might appear like, but it doesn't mean it's going to be quantifiably related to circadian rhythms. Now, you can also have, and this is another important point, you can have a fixed spectral power distribution, or you can have tunable. And I want to emphasize, or you do not have to have tunable spectra to promote circadian entrainment. You can take a fixed XPD, and as long as you're delivering 0.3 for 2 hours, you will meet the Tier 2 P100 requirements. You then run your photometric simulations, and what you want to do, we use AGI 32, but any of these photometrically realistic software packages will give you pretty much the same result. You then look at the vertical illuminance that's at the occupant's eyes, and you want to have, we say in this where it is, you'll see here it's between 0.9 and 1.3 meters above the finished floor. So it's that vertical illuminance at where the occupant would be sitting, which is the critical measurement you want to simulate in this particular software. Now, we say to make it easier, a minimum of 10 locations within the space if you know where the locations actually are. But if you don't, you lay out a grid, you do take an average of that because you don't always know where people are going to be sitting. So either technique will meet the design guide of 24480. Now, when you're running these photometric calculations, another important point I want to get across to you, you do not have to generate all the light out of the ceiling. It's much more effective to get vertical luminance at the eye by things like luminous panels, for example. It's a great way to save energy. If you then tune it to, say, blue in this particular case, that's also, remember I said it was a blue sky detector. That's a very effective and very efficient way of delivering that CS. We find that people are kind of stuck in the ceiling. It's not the best place to deliver circadian effective light. So we'd like for people to begin to think about layers of light rather than everything being pushed out of the ceiling. You then take your calculated vertical illuminance, the SPD, and then you run it off this free calculator. That's the link that you get there. And you have to, again, have the SPD and the vertical illuminance to make this calculation. What generally happens is you don't get it right on the first try. So what you have to do is you run the software, you see if you make the criterion, and then you have to go back by changing the luminaire, changing the spectral power distribution to see if, in fact, you are going to meet the P100 requirements. So again, this is new. And if you don't make it the first time, play around with luminaires, play around with spectrum, begin to think about layers of light on how you're going to meet this. So we're not prescribing how you do it. We're only prescribing, if you will, what goal you need to meet, and then we give you the tools to be able to see if, in fact, you did it or not. Now, I want to make another point. It's this last one. As you increase light levels, you run the risk of increasing glare. And that is not going to be satisfactory for a lighting design. And what we have shown time and again is that if you have a bare LED, you may meet your number, but that's not anything anybody's going to look at. So what we do is we try to distribute that light over a larger area. So it becomes the luminance rather than of the object, of the surface, rather than illuminance to the eye. So this is a requirement in the P1, in the design guideline. You should not exceed 8,500 candelas per meter squared. To give you a sense of what that is, that's the luminance of the blue sky. So on a clear day, you look outside, that is the brightness that you will get from a blue sky. It's also, coincidentally, roughly the luminance of a T12 lamp, not T8 or not T5, which are much, much brighter, exceed that luminance, but it gives you a sense, those of you who've worked, if you still remember what a T12 is, that is the luminance or brightness of that. It's also equal to that of the blue sky, as I said.
Predominantly today lighting is LED, and T8, T12, those things are kind of obsolete in most federal buildings. So is there any way we can get real solid firm guidelines for LED to the topic that you are discussing?
Yeah, I only use them as example, thinking those of you would familiar with that old technology, that obsolete technology. I don't remember the last T12 I saw, except I think in the subway of New York City, they still have T12s. But anyway, no, I only use this as an example. I'm not saying that's what you should use or anything like that. I was trying to give you a sense of scale. No matter how you produce it, whether it's a fixture or a bare lamp or whatever, it should not exceed 8,500 candelas per meter squared, period. So however you do it, whether it's with LEDs or whatever, that is the limit of the luminance you should allow to minimize glare.
Thank you.
So
Yeah, that's a good guidance.
They were just examples. I'm sorry if I distracted you from bringing us back into the early 90s. Sorry about that.
Thank you.
So what I think is important is to show you some examples of how things might work. So here's a simulation, open plan office, medium height partitions. And what we're going to do is we're going to say in this particular example, from 7 a.m. to 4 p.m., we're going to have a CS of 0.3. Now remember, we don't have to run it that long. This is just an example. We need a minimum of 2 hours, so this meets. So if you look at the 2700K, for example, you see a vertical illuminance EV of 345 lux. This is what your conventional light meter would read. And then as you progress through the day, you want, again, remember, bright days, dim nights, you're going to drop that to maintain circadian entrainment for those people that come in after 8 o'clock to very low light levels. In this case, for the 2700K, 90 lux would be your criterion to measure and specify. Now, if you jump all the way to the right and you look at a 6500K lamp, what you see is that we went from 345 lux at the eye, vertical illuminance for a 2700K to only 195 lux at the eye for vertical illuminance. So spectrum matters, but I want to point out that that is less than a factor of 2. So all the way for white light sources, whether you're talking 2700, which is about as warm as you're going to put into a space, to 6500, which is simulating daylight and as cool as you're going to have, you've got a lever of a factor of 2. Now, I want to make the point that all of this light is coming out of the ceiling. If you were to bring that layer of light closer to the eye, you would not need that. You would still get 345 or 195, but you would not try to do it all through the ceiling. So I want to make it clear that this particular simulation just shows you what the numbers are, but this is not a recommendation of what you should do. In fact, this is probably not a great solution for delivering a CS of 0.3. All of those will meet it, some of which are more energy intensive than others, but I want to make it clear you do not have to waste energy to meet that criterion. Think about layers of light and not trying to push all those photons out of the ceiling. Now, in the guideline, for those people that are frightened of calculations, I don't think anybody here is, we also have an alternative that you can use. So what we're saying is, look, forget about all that. Just deliver 500 lux at the eye and you'll be okay. It's wasteful, but you will be able to do that. So in our library of all LED sources we have, and we have like 160 in our library, and we took the cool ones, which is 16 of those, all of them will pass the criterion of CS of 0.3 in this simulation at 350 lux. If you then look at something between 4900 and 3100, you will be guaranteed that if you're picking a light source with that CCT and the proper SPD, remember it's not just a CCT, 400 lux at the eye will get you there. And if you want to go with a very warm source, you are guaranteed from the source of our library, if you deliver 700 lux vertical, you don't have to think about it. Now, what we recommend is if you don't want to go through the process of the simulations and all that that we've recommended up to this point, if you just deliver 500 lux at the eye, you will cover, no matter what LED, 90% of whatever LED you pick. We're trying to make it easy. You don't have to have a sophisticated calculation, a lighting design. You can do this with illuminance, just conventional illuminance. But remember, it's vertical illuminance at the eye that becomes important. So this is a shortcut, maybe useful to you, maybe not useful to you, but we wanted to show that you can do it this way. Now, the design verification becomes important. I think, again, we're getting past good intentions. So what we're recommending is that these values, the vertical illuminance at the eye, the horizontal illuminance, and the CS be documented. So write down what it is you want to achieve, CS of 0.3 or CS of 0.4, whatever it is you think is appropriate. You want to have detailed description of your luminaire and your light sources. Remember SPD, not CCT. You want to show that you did the photometric calculations, and you're going to have to assume in those calculations what typical reflectances are going to be. So nominally walls are 50%, ceilings 80%, floors 20%. They could vary, and that will also affect how much light actually reaches the eye. And of course, daylight becomes another consideration. So then you want to, if you reach that criterion, we say you should document that you did the design and this is the values that you got. Now, you go to measurement verification. Now, you can do this with a conventional luminance meter, the reported or SPD from the manufacturer, spectral power distribution from the manufacturer, and the CS calculator to get you to decide whether you did, in fact, meet that criterion. You can also use what are called portable spectroradiometers that automatically look at the spectrum and the amount, and some of them already have software that includes CS as an output from the software. So you can do this with a $1,000 instrument, or you can do it with a $300 instrument, but you have to do the calculations that go with it. In every case, though, you should have a minimum of 10 representative samples. You don't want to measure it, you know, in the closet or in the hallway. You want to do it at the workstation where that occupant is actually going to be spending most of her day. Now, this is an important thing, and to my knowledge, I was editor-in-chief of 2 editions of the IS handbook, and recommendations are often provided without accountability. So if you say, well, we're going to light our street to, 18 lux, whatever that is, there is no promise that that's going to reduce accidents. That's never brought up. It's never done. In this particular case, with the design guideline, we have what's called verification of effect. And what we can actually measure with light sensors, you can see the light sensor that is worn as a lapel pin here, a watch that looks at your activity. We can look at the synchronization between the activity rest or sleep and activity and the light dark cycle. So the top row represents a person who is entrained. We predict that that person will sleep better, have less depression than average of people that would be otherwise in a sort of a random environment. Now, the one below is actually for a shift worker. What you can see is there's an uncoordinated exposure to light in the blue traces, which is the input to the system, and the output is your activity. Those people, we predict, will have sleep disturbances, more depression, have a harder time falling asleep. So we're actually suggesting, and I hope that some of you pick this up, you take a sample of maybe 25 occupants of a space that you've built, and then you divide them into 2 groups, and you find those that are being exposed to bright days and dim nights as opposed to those that are getting low light levels. If they're from Fairbanks and they're not pulling their shades down at night, or they're not getting bright light during the day, we predict you should be able to demonstrate this recommendation actually works. And again, to my knowledge, after editing 2 editions of the IAS handbook, this is the only recommendation I've ever seen that promises a value that you can actually measure in the occupants you're trying to treat. So I thank you for your attention. I hope you gather I'm rather enthusiastic about this and deeply grateful to GSA for the opportunity to work and hopefully improve the quality of life of the people that occupy your buildings. So I am happy to answer questions. And by the way, if you think of something down the road and you want to just email me, you can do it through Brian, or you can contact me directly. I'd be more than happy to try to answer your question.
Thank you, Dr. Ray, for a great presentation. I'm curious if we could speak a little bit about the Denver Federal Center case study, I guess I would call it, that where you actually achieved the CS of 0.3, certain spaces and other spaces did not, just to sort of shed some light on the type of office space where it's more achievable.
Yeah, and anybody can jump in here. I'll give you my impression. This is the first verification. This is the design verification, right? So this has not been built and we don't have people occupying it. So we're only talking about the design verification.
Sure.
It did seem to guide the way the building not only was lighted, but how it was laid out. I think that for those open areas, it looks to me, again, looking at the drawings and the report that we got from the engineers there, that in fact they will have a CS of 0.3 or higher by a combination of daylight and electric lighting. I think the thing that worries me a little bit is that the private offices do not have that criterion. Now, I don't mean to be critical, but I think it comes with a mindset that all the lighting has to come from the ceiling. So this may be something that GSA can't do, and that is to recommend, things that go on your desk or things that might be on the wall. I don't know the answer to that question. So the way they dealt with it was they were going to allow people to come to more public spaces and bring their laptop with them and work there to get their CS of 0.3. And I think that's a really good idea, right? You don't have to just sit in your desk all day, but if management allows you to go to sit to an atrium or something like that to get your CS of 0.3 for 2 hours, biologically that's going to be exactly the same as if you had it in your office and you never left it, having a CS of 0.3. So I guess what I would say is, in summary, that it doesn't all have to come from the ceiling, and it doesn't all have to be electric lighting. You can actually change your management strategy and achieve what you need to do.
I'll just jump in, not a question really, but just a statement that if you asked me a year ago, circadian lighting, I would have said, the pie in the sky stuff, we're never going to do it. Forget about it. It costs too much. And then Ben and I, we met with Mark a few months back there, and he told us what he just told us right now. And it kind of dawned me like, this really is possible. This is something that can be done. It's not going to break the bank to do it either. So it kind of brightened the possibilities to me, if you will. So I hope it did for some of you folks out there too, because it was really something I wasn't even thinking of until I heard him how it can actually be done.
Well, this is really, thank you, Jeff, for that comment. This is a testament to the balance committee, the task group that participated in the recommendations. They were very conscious of energy requirements because you do need brighter light. And so the whole idea of trying to get it down to minimally effective was really always with us when we came up with those recommendations. That's why it's not daylight levels. That's why it's not 8 hours a day, is we wanted to get it down to a dose that was effective, but not necessarily over-designed. And I think that's, again, a testament to the process that UL requires us to go through.
I would second that, Jeff. After the previous presentation we listened to, obviously the general rules of thumb are more access to daylight, vertical foot candles, which is lighting from the side in simple terms, which we don't normally do. We light from the ceiling, as has been mentioned here multiple times. Task lighting may benefit. Cove lights, wall wash, light panels on the walls, those sorts of things I think we need to be thinking about more so when we're doing our lighting designs.
Well, I think it opens up a whole new avenue of creativity for lighting design.
Definitely.
And I think opportunities for manufacturers to come up with new products. So I think, but you need to engineer to something. So that's why it's important to have a metric, right? Otherwise, it's just good intentions.
I just want to also clarify that the requirement for the circadian lights are part of P100. And how do we include this requirement in the scope for the project manager across the nation so they can include that and make sure that the AE are aware what are our requirements and how they will include that in the construction design build or in the CDs moving forward, and also making sure that these are the building design standards for every single building nationwide.
Yeah, it's in the P100, but it's under the tier levels. So you need to specify that tier if you want to bring circadian into your project.
So it's an option. It's not a base. Normally, all these repair and alteration, they go to base unless they ask for extra requirement for certain.
Yeah, correct. Level. Yeah, correct. You'd have to specifically call it out right now. Yep.
Okay. Same thing with GSA. All GSA building are. How do we deal with that? It's not in the basic. If we need it, we ask for it?
Currently, yes, that's how you would go about it. It's possible in the future it may find its way into the baseline level. This may very well be more achievable for this tier as maybe some of the other tiers that we have in P100, at least at this time.
Is there an approximate cost increase, like from general lighting to circadian lighting per square foot? Or does that depend on the building type?
Well, I'll say yes, either because you may have to specify more fixtures, or if you try to get all those photons out of the ceiling, you may have a higher energy requirement. But we've done practical applications of which I'll say we're not talking about a doubling of the cost. I mean, it's maybe only a few percent. I think one of the problems we're facing with you can't really specify circadian effective lighting. What would you say? So the burden on the designer right now is to think it through. But in that thought process, I'm sure cost and energy are going to be part of those considerations. But right now, it falls a lot to the designer who grasps what the importance is and then has the ability to look at things that are not advertised as circadian effective and interpret them as something that could be used to have circadian effective lighting. So I think there's a missing step there, that we're not really helping the designers to actually select fixtures that have been shown to be effective and things like that. So I just think there's a lack of education and understanding, but it doesn't mean you can't make an existing product work. But you have to know what your end goal is to make it work. Well, how about the Denver thing? I mean, was that I don't know if you know, Ben, was that a big increase in cost, or do you know?
I'm not 100% certain, but I don't think so, because there was so
I don't
much
think so
daylighting.
either.
Yeah, there was so much daylighting for the area that they were able to meet the 0.3 CS. And then I asked the specific question of what would you have to do in those individual offices to gain that, and they said they would have to double the horizontal light output. So I think as a lighting designer, we really need to look at those vertical foot candles, which is a little different than what we've done in the past, and see what type of fixtures that will get us there, using AGI 32 or other lighting software calculations, whether it be a cove fixture or something that's, lighting from the side. If anyone's ever designed any sports stadium lighting, which I have in the past, vertical foot candles are extremely important, and they're very hard to get. That's why when you see a football field or something, the lights aren't overhead, they're coming in at like a 45-degree angle in order to gain those vertical foot candles. But it's difficult to do with strictly overhead lighting. So I just need to change that mindset and maybe experiment a little bit. But then also take in the integrated design approach, to where it's not just a lighting designer in a vacuum doing this. They're working with the architects and building enclosure experts and things to pull this all together to achieve this effective lighting.
And sometimes a bucket of paint can do well, right? If you increase the reflectances of the walls, you're more likely to have it, right? So that presumably isn't more expensive. I can't give you a direct answer, Rami, because I don't think there's a database to look at how different approaches were and what the costs were and so on. So it's a little bit of a hand waving on my part. I apologize for that, but we're at early days.
No problem. I'm just asking because, we have to come up with an estimate ahead of time to get funding.
Course.
So.
Of course.
I want to thank you guys for being with us today. Great presentation. I think it certainly shines some light on a topic that was a bit confusing to a lot of folks. So thank you.